Okay, so you're welcome to the next session. We'll talk about the cumulative distribution function. Okay, so just like we did in discrete variables, when you talk about the cumulative distribution function, it's just um, a summation, right? So it's just the same concept from what we did in discrete variables. So let's say you have a dice and you toss, you know that for each round, right? So for 1, 2, 3 to 6, you have 1 on 6 chance for each, right? But then if you talk about cumulative distributive function, then you'll be adding up. So here you have 1 on 6, 2 on 6, 3 on 6, so you get 6 on 6 here. So that's just the major idea behind cumulative distribution functions. Okay. So just like we did in discrete variables you define a cumulative distributive function like this, right? But then when you're working with continuous distributions like what we are doing now, you have to define it in terms of this, right? So you define it as negative infinity to x, that particular value you are dealing with, times the integral of the function dt, right? So basically, if you are dealing in if you are dealing in discrete variables, which we are not now, then for f of 3 it will look like this, right? And then if you had a function of it, then you could just have your probability at, say, let me just say your f of x to be some integral from negative infinity to x of, say, maybe 2y plus 2 dy, something like this. Yeah. Okay. Okay. So in the as we continue, I'll just relate everything to discrete variables because that's what we've done before. And then Um, so in continuous variables, you can also find your mean, standard deviation. Your mean is the same as the expectation, right? So remember, if you have your mean like this, the same as your expectation of x. In discrete variables, it was xp of x, right? Then you just sum it up. But then now you're talking about continuous variables. So you trash this one and say your mu equals expectation of x equals the integral from minus infinity to, say, positive infinity, or wherever it will end, of x f of x dx, right? I hope this one makes sense. So you can have your variance equals um, right, okay, and in the same way you can have um, your standard deviation equals your expectation of x squared minus mu, or sorry, mu of x. It's the same thing. So whether I write mu of x or mu squared, right? So basically, these are the formulas you're going to be dealing with. Or if like they give you the question, you don't want to go through a long method, you can just use so if you just want to find your standard deviation, your standard deviation squared will be equal to your variance. If this one looks confusing, okay. So let's just find an example here. So he says that a random variable has a probability distribution function, or a probability density function of, say, fx. So f of x, so fx of x equals a piecewise function of c1 minus x power 4 and 0. So this one is from minus 1 to x to 1, and then this one is for elsewhere. Okay. So now the first question is find c. So how do you find c? Okay. So to find c, you have to integrate over this period, because you know that for probability distribution functions, you know that the everything here sums up to 1. So if we do that here, then we should get it. So we say that um, the integral from minus 1 to 1 of c multiplying 1 minus x power 4 all equals 1. So in this case, we are assuming that c is um, a constant. Okay, we assume that c is a constant. If c is not a constant, then we are doomed. So here we say c into, so we have c multiplying. If you integrate all of this, you just get x minus x power 5 on 5. This is quite straightforward. Equals 1. Then if you want, right, you have minus 1 to 1. So you can do your subtractions. Then you have c into bracket 1 minus 1 on 5 minus, there's a big bracket here, and then minus 1 plus 1 on 5, okay, equals 1. Yeah. So with this, if you simplify, you'll be getting c times 8 on 5, right? You can try it out and see. Then this means that your c will be equal to 5 on 8. So let me just bring this up here. So that means that c is equal to 5 on 8. Now 5 on 8, if you want, you can break it down to your decimals, and you have this. So basically this is the first one. So just going over. So to find your c, you just have to integrate over this equals 1, because that's the rule we learned, that the whole summation gives you 1 over. So just saying that is the area under the graph, right? Area under the graph gives you 1. Okay. Okay, so let's move on to the next thing. I don't remember how I read this. Okay, so we have a. Okay, so the next thing is to find. Let me check it out. Yes, so they now want you to find your cumulative distributive function. Right. Good. So now, how do we find our cumulative distribution function? Now we know that for f of x less than 0, yeah, okay, less than minus 1, sorry, less than minus 1 gives us 0, and f of x greater than 1 gives us 1. Okay, okay, yeah. So we'll have to work on to find so we'll be working on finding minus 1, so minus 1 1. So basically this is what we'll be working for in finding a continuous distributive function. Okay. Okay, so let's do what we normally do. So we just say the integral. So we just integrate this over minus 1 to 1. Now we know our c to be 5 on 8, and we are subtracting 1. What is it? It's x power 4. Okay, and then dx. So basically this is. Oh, you can leave it here, but then you would have to simplify that, right? Because it's in the integral form. So all you have to do is just to simplify this, and you have your continuous distribution function. So we end up having 5 on 8. Then now we have our x minus x minus what, x 5 on 5. Then you have your minus 1 to 1. Okay. Okay, so basically, um, I hope you've noticed that there is some redundancy here. So we are not taking it to 1, we'll take it to x, right? Because if we take it to 1, then we just end up with what we'll end up with. So you realize that we did this here, okay? So if we do this, guess what we'll end up at? Good. So I just allow that for you to ponder over. So basically, when you come here, you have your 5 on 8, all of this. Then you can simplify this down. When you simplify it, it will come up with the same thing. Sorry. So first of all, you have this itself. That will be x minus x 5 on 5, all minus minus 1 plus 5 1 on 5. Okay, sorry. And then so this will give us 5 on 8 multiplying x minus x 5 on 5 plus, right? So that will be plus 4 on 5. Okay, so basically this is a continuous distribution function over minus 1 x 1, or basically say x, because we want it in a function form. I hope this makes sense. Okay. So when you are defining your CDF, you don't define just this. You define all three. You define all three. Okay. So when you're defining, so let's just go over. So when you're defining your CDF, so we have three ranges, right? So we define it from x less than or equal to from x less than minus one actually, and then we define it from minus one to one, and then we define it from x greater than one. And then here we find that this is zero, this is one, and then this one is that function we found down there. I hope that's fine. So you can check it out again if you want to solve it later on. Okay. So in the question, the next thing is say, so they say find the mean. So find, if they ask you to find the mean, so the mean is the same as your the expectation, right? Sorry. Okay. Now, at the beginning, we define this as the integral between the points. So minus one to one. Sorry for the camera. Minus one to one of f of x, f of x, dx. Okay. So with this in mind, let's just get to it and see how we find the mean. We know the function of this. So what will be our x, right? So basically, it's just one part of the general this one. So when you solve, because you have two limits, you would find it easily, right? So you have 5 on 8 multiplying x minus x 5 on 5 plus 4 on 5, right? I guess this was it. No, sorry. So this is not it. Okay. What I'm using here is the CDF. So we have to use the main function. Sorry. So we have integral from minus one to one of x multiplying the function itself is 5 on 8 multiplying 1 minus x 4. Okay. All the x. Sorry for the initial error. Okay. Okay, so with this, right? Yeah, definitely. Okay, so with this, let's move on to do our. Sorry, this is x, not times. I cancelled it because I thought I wrote times. So now let's multiply through. Then we get minus 1, 1, 5 on 8, x minus x5. Okay, dx. Then we integrate this. If you integrate this, you get I like to write it this way. You get s squared on 2 minus x 6 on 6, and then you have from your limit to 1. Right? And then with this, if you want, you can use your calculator. You can. Okay, so from the way it looks, I hope you can see just that it would end up in a zero, right? Just from the way it looks. So from here, right? So you have 1 inside each of these, so that would be half minus 1 on 6. Okay, this one minus um, what happens here, that would be half minus 1 on 6. So basically these things will cancel out, and then you get 0. Right, so that's the mean of this distribution is 0. Yeah, so the mean is 0. And then from here they can ask you to find your variance, right? So to find your variance will be basically e of x squared minus e of x all squared. Okay. Um, this is your mean, which is 0. So you can come here to find this. So with this one, you solve it with the formula again. That will be integral from minus 1 to 1 of x squared times f of x, which is 5 on 8, 1 minus x4 dx. Okay. Okay, so with this one you can simplify it down. So this one, if you have to simplify this down, you get your 5 on 8 minus 1 to 1. So x squared minus x 6 dx. Okay, so this one you can follow the same integration technique we used, and then yeah, so with this one, just follow the same integration technique we used. You would find that your variance would be equal to 0.0952. Okay. But then if you find something different, you can put in the comments. I'll check it out. So you get 0.092, or you can just use your calculator to confirm. Yeah. Or and then if they ask you from this point to find your standard deviation, then your standard deviation will directly be square root of variance, which will be your 0.0952 square root of that. And then they should be giving you something around 0.31. Okay, so basically that's just it. Okay, so let me just summarize the question. Okay, so we found C to be, and then we find our mean to be 0, right? Then we found our variance, which is this square, to be 0.0952, and then if you are asked to find your this, then that will be 0.308 or so. Okay, so this is all for the first example. There's another example. So there's another example that says that we're working for f of x, and then your piecewise function is thrown to 1 minus x squared. So from 0 less than or equal to x less than or equal to 1, and then we have otherwise. So here it gives you 0. So now you are asked to find 1, find your CDF, and then 2, calculate the mean or E of x. Okay. So to make this video also short, I'll just put the answers down, and then you solve it too and see what you get, and then send from there. Uh, so when you compare, then maybe they are different, you can just put it in the comments so that I'll check it out. Okay, so in this case too, you would have to find your ranges, right? So you need to find for your f of x less than 0, equal to 0, and maybe probably greater than 1. So if you are finding for your f of x between 0 and 1, right? So between 0 and 1, then you have 3 on 2x minus x cubed on 3, right? So this is what I had for that. And then if you are working for, oh, we're not of this. Okay, so this will be it for the first one, right? And then if you are working for f of x greater than 1, and then you also consider f at 1, then you'll be getting something like 1, right? You'll be getting something like 1. So so in that case you end up having like 3 possibilities. So you have 3 possibilities. So you have 0 for x less than 0. Okay, you have your 3 on 2 times x minus s cubed on 3 for 0 less than or equal to s less than or equal to 1, and then you have 1 for x greater than 1. So basically this is so this will be your CDF. Okay, so basically this whole thing is not so difficult. It's just the way you try to understand it. It's not that difficult. And then when you calculate the mean, so you calculate the mean with E of x, which is the same thing as you integrate from 0 to 1 of x f of x dx. Then this one should be giving you about 3 on 8. So this is your mean. So you can solve it and then see if you get the same answers, and then we can discuss it moving on. Okay, so thank you, and then I'll just break this down and then move to the next session. So the next session will be on the uniform distributions. Okay, thank you for watching.